Okay, so welcome back. So here we're talking about what's called telescoping series. This is another series like geometric series where if it converges, we're actually able to tell exactly what it converges to. Now, we get the name telescoping series because of the old style telescopes. Old style telescopes, so you can see here that as you pull it out, right, it comes out. Think like a lightsaber, like the plastic lightsabers, that same kind of idea, right? So this is called telescoping because if you have this telescope all the way expanded out, well then, right, it just goes right back in, right? And so that's what happens with this series is all of the stuff in the middle goes completely inside, right? Everything kind of gets absorbed and you end up with just a couple terms at the beginning of the sequence and at the end of the sequence. So that's why we get the name telescoping series. And so here, consider the sequence here, 1 over k plus 2 minus 1 over k plus 3, as k goes from 1 to infinity. So let's start looking at the first few terms of this sequence. So this would be 1 over 1 plus 2 minus 1 over 1 plus 3, and then plus 1 over 2 plus 2 minus 1 over 2 plus 3, and so on and so on and so on. So I want to write the first few terms of this sequence out. So I'm just going to actually do a little bit of simplifying here. So this is going to be 1/3 minus 1/4 plus 1/4 minus 1/5, and then that would be plus 1/5 minus 1/6 plus 1/6 minus 1/7, right? And that would continue on until eventually you would get to n. We're just going to do it up to n is where we're going to come to. We're going to continue our sequence up to n. So at n, this would be 1 over n plus 2 minus 1 over n plus 3. And then this would continue on and on forever. Okay. So what we want to talk about is the nth sum when we go up to n. What does that equal to? And it turns out we can actually generate a formula. Because notice that a lot of things here cancel out. The minus 1/4 from the first piece is going to cancel out with the plus 1/4. Right? The minus 1/5 from the second piece is going to cancel out with a 1/5 from the third piece. The minus 1/6 from the third piece is going to cancel with the 1/6 from the fourth piece. And then that 1/7, well, that's just going to cancel out with whatever what's occurring in the next term. And likewise, that 1 over n plus 2 part here would have canceled with whatever was the previous term, right? Because the previous term would have been 1 over n plus 1 minus 1 over n plus 2, right? And so everything cancels out on the nth sum except for the 1/3 at the beginning and the minus 1 over n plus 3 at the end. And so therefore, right, we can now talk about what happens to the overall sequence as we look at the limit of the sequence of the partial sums. So we would say limit as n goes to infinity of Sn. That would be the limit as n goes to infinity of 1/3 minus 1 over n plus 3. And as n goes to infinity, 1 over n plus 3, that's going to go to 0. And the limit of 1/3 is just going to be 1/3. So this thing is just going to be 1/3. This thing is just going to be 1/3. Okay. And so we can get a little feeling here now. For this thing, even though it is an infinite series, it is going to converge to 1/3. It's going to converge to 1/3. Okay, so let's take a look here. I've actually put my formula for Sn in, and then set my table up to be auto-generated, right, by going into the table setup, starting at 1, increment 1. Right, that's what the TBL is on mine, and I hit enter to set independent to auto. Right, and now looking at my table here, you can see that when x is 1, it's 0.5833, and we keep going through looking at the different values, and it's going to take a little while, but we can see if we keep going, like I said, it's taken a while, a lot of terms before it really starts getting close, but you can see it's starting to kind of settle down as we get closer and closer to 1/3. Right, here we are. 206 is 0.33812. All right, so it's slowly getting there. All right, of course, we'd have to go all the way out to infinity to actually see that it does go to 1/3. Okay, so this is an example again of a telescoping series. And we're actually going to look at a couple of other examples with telescoping series coming up in the upcoming videos.